All right, let's have at it here. So I want to, I don't know, it's probably going to take the next 15, 20 minutes to go over this. When I was not here on Friday, I had you guys get into a group. Hopefully the sub had you do that. So you guys got into a group. You thought about, I see people laughing like, no, we didn't do that. He just threw stuff at you. All right, anyway, let's talk about what you were supposed to do last class. So Mythbusters was about the age-old myth of a bullet dropped versus a bullet shot. All right, so before you watched the video, what I wanted you to do was get into groups. He was supposed to propose that age-old myth of what would hit the ground first, a bullet dropped or a bullet shot from the same height at the same time. So I'd pull the trigger, I'd drop the bullet at the same time. All right. Generally, when I do that, the class is kind of split. They say, oh, the bullet dropped will hit first or the bullet shot will hit first. Some people say, oh, they're going to hit at the same time. The truth is, guys, they will hit at the same time. All right, so what I wanted you to kind of get out of last class when I was having you look through the note packet was, so if we have a tabletop here, all right, and we were to take a tennis ball and we were to roll a tennis ball off the table and we were to drop a tennis ball from the table right when it hits the edge, they're going to hit at the same time. All right, so if you looked at your note packet, this one right here that I think JP has out, one of the pages in very big bold says this: the horizontal component is independent of the vertical component. So what that means is, regardless of how fast it's moving this way, gravity still has the exact same effect on it and is going to pull it down at the same rate. So if I roll a ball off a table at 3 miles per hour and I roll a ball off the table at 20 miles per hour, what's the outcome going to be as far as falling time? So we have one that's going at 20 miles per hour. Let's use metric. 20 meters per second off a table and 3 meters per second off a table. As far as falling time goes, what's the relationship between those two? Same time. Exactly. So how fast an object is moving horizontally has no effect at all on how fast it gets pulled down. We know that the acceleration of gravity, guys, is 9.8 meters per second squared. So regardless of its horizontal speed, it's still going to be pulled down at 9.8 meters per second squared. So think back to when we were doing that tennis ball lab. Remember the lab that we did where we threw the tennis ball up to measure the heights of objects? And I told you that if you wanted to measure something tall like the flagpole, so if we have our flagpole here, that's a pretty thick flagpole. I'm not happy with that drawing at all. Let's do it again. So if we have our flagpole here with our waving flag, all right, I told you that you can, gentlemen, I told you that it's okay to step back and throw the ball at an angle. So if you threw it like this, or if you threw it straight up and it came straight back down, it wouldn't matter, all right? And this is exactly why it doesn't matter. We're going back to something we did a while ago. Because the horizontal motion is independent of its vertical motion. So regardless of what its speed is this way, the rate at which it's going to fall due to gravity is going to be the same, all right? So that's why when you watch the Mythbusters, the drop bullet and the shot bullet, yeah, the shot bullet has a humongous horizontal velocity, while the dropped one has no horizontal velocity. But looking back at that statement where the horizontal component is independent of the vertical component, they're going to hit at the same time because they're coming from the same height. Okay, that's the basis of that. So what I then wanted you to do was, I gave you an example, 2 examples, I think, in the packet of how to solve these problems. I want to go over those today. Once you start, once you can do one, you can generally do all of them. I've realized that the easiest way to teach this, or I should say the easiest way to learn this, is to separate things into 2 components, a horizontal component and a vertical component. All right? So we are going to be using 3 different formulas here. S equals dt, so what's that for? Speed, horizontal speed, all right? Not in free fall. This is, if we wanted to find the object speed in free fall, Remember, it's got a G in it. That's what is used for free fall. So this is a X problem. So think about a graph. All right. The X component is going to be the horizontal part of the graph. The Y problem is the vertical component. So let's look at number 1 here. It says a stone is thrown horizontally with a velocity of 3. The tricky part is, I think where I generally see kids having trouble is deciphering which box to put the numbers into. So it says a stone is thrown horizontally with a velocity of 3 meters per second. First things first. Meters per second. What is that giving us? What unit of measurement is that? Speed. And it's being thrown horizontally. So therefore, this is the horizontal motion box. I'm going to put 3 right here for speed. From the top of a cliff that is 122 meters high. What's measured in meters? Distance. Now the question is it going to be a horizontal distance or a vertical distance? Is everyone's paper different? This is your homework for tonight. Let's switch it up here. How's that one looking? Much better. All right, take 2. Here we go. All right, let's look back here. Same thing now. Just a new problem. It says a ball rolls with a speed of 2 meters per second across a level table. That is 1 meter above the floor. So the ball rolls with a speed of 2 meters per second, so we know that's the speed. Or it could be a velocity, all right? But the question is, it says across a level table. So I always just kind of act it out. It's going this way, across a level table with a speed of 2. So that's going to be horizontal, all right? So I'm going to put a 2 right there. Across a table that is 1 meter above the floor. So if we're looking at a tabletop, it's 1 meter above the floor. So is that vertical or horizontal? Vertical. So I'm going to put 1 here for distance. Upon reaching the edge of the table, it follows a parabolic path, which just simply means that. How far along the floor is the landing spot from the table? Now, there's one thing we can fill in here still that it's not given to us in the problem, but we know it automatically. G. I'm going to use 10 just to make the math a little bit easier. Ultimately, how far along the floor is the landing spot from the table? So if here is the table, I want to know how far along the floor is the landing spot. So this is going to be a distance. What kind of distance? Vertical or horizontal distance? Horizontal. So ultimately, this is what we're trying to solve for at the end. Okay? Now, this goes back, like I told you before, guys. We are going to use these equations a lot in here. So we're going to solve for time because we have D and we have G. So if we do the math, we're going to set it up. D equals 1/2 GT squared. We have a distance of 1. We know that G is 10, and we're solving for T. So 1 equals 5T squared. Have to divide out the 5. Remember, you cannot subtract the 5. That's a big mistake I always see. You have to divide it out since it's multiplication. So we get 0.2 is equal to T squared. What do we have to do now? Square root. To get rid of the square sign, the square root of 0.2 is going to be 0.2 square root 0.4, about 0.45. So here is the trick, or wouldn't call it a trick. So we know that time is 0.45. Something you need to remember, guys, is your vertical time is always going to be the same as your horizontal time. So if you get time in one box, you can transplant it in the other box. And let me explain that here. Oops. That's not good. I think I just erased everything. Sure did. So this was 0.2. This was 1. This was 10. 0.45, 0.45. If we have something horizontally projecting off of a table, and we know that the horizontal component, the speed it's going this way, has no effect on the speed it's falling, the time that it takes to travel this distance is the same time it's going to take for that object to hit the ground. Right? So therefore, your vertical time is always going to be the same as the horizontal time. Whenever you solve for time, you can put that right up in the other box. All right? Now, look what we have. We have a speed and a time. We have a speed and we have a time. Now we can solve for the distance that it's going to shoot off of the table. Little trick here. Use the triangle. Speed equals distance divided by time. We have a speed of 0.2. We have a time of 0.45. We are trying to solve for distance. If, yes. Perfect. Thank you. Two. Lovely. So now, if they're next to each other in the triangle, what are we going to do? Multiply. Yeah. If we had two numbers on top of one another, what would we do? Divide. Exactly. And there it is. So what that means is, if a ball rolls off a table with a speed of 2 meters per second from a table that's 1 meter high, it's going to land 0.9 meters away from the base of that table. Okay? So any questions with number one? We're going to do all of these here so you can see that once you can do one, you can do them all. Can I move on to number two? What's up? If I don't ask you to find its falling velocity, no. Okay? All right. Number two. A rescue pilot drops a survival kit while her plane is flying at an altitude of 2,000 meters. So if a plane is flying at an altitude of 2,000 meters, we know meters is a distance, is it a horizontal or a vertical distance? Vertical, 2,000 meters above the ground. So I'm going to write 2,000 right here. With a forward velocity of 100 meters per second. So the plane is traveling like this at 100 meters per second. Is that horizontal or vertical? Horizontal. So her horizontal speed is 100. If air friction, which we always disregard, how far in advance of the Starving Explorer's drop zone should she release the package? So again, ultimately we're solving for this. We want to know how far ahead is she going to drop it. What can we fill in here still? G. G is going to be 10. Now we're going to solve for T again. We have a D and we have a G. So D equals 1/2 GT squared. Distance is 2,000. 1/2 times 10 T squared. 2,000 equals 5 T squared. Divide out the 5. We are left with 400 equals T squared. Drop a square root on it. Square root of 400. No, I don't even need to do that. Duh. 20. So what that means is this. The time it's going to take to hit the ground is 20 seconds. The time it's going to travel, whatever horizontal distance, is going to be 20. So now I always like to set this up, just speed equals distance divided by time. Speed is 100. Time is 20. We're solving for distance. What's the distance? 2,000. So now, it is a coincidence, guys, that these came out the same. Your distances, vertical or horizontal, are not always the same like your horizontal and vertical times. Okay? So that is So you're seeing once you can do one, you can pretty much do all of them. So any questions on number 2 here? All right, let's look at 3. It says a rifle is fired horizontally and travels 200 meters. I should say a bullet has traveled horizontally. It travels 200 meters, so that is my horizontal distance of 200. The rifle barrel is 1.9 meters from the ground. Where am I going to put that 1.9? Vertical distance. Good. 1.9. What horizontal speed must the bullet have been traveling at? Well, ultimately, we're trying to find that. But before we can find that, we must solve for time. We know gravity is 10. Surprise, surprise, we're going back to this formula. Distance is 1.9 equals 1/2 times 10 t squared. 1.9, half of 10 is 5 t squared. Divide out the 5. Then we do 1.9 divided by 5. 0.38 is equal to t squared. Pop a square root sign on there. About 0.62 is the time. So it's going to take the bullet 0.62 seconds to hit the ground, and it's going to take the bullet 0.62 seconds to travel 200 meters. But we want to know what the speed then was of that bullet. Speed, distance, time. Distance is 200. Time is 0.62. So now they're not next to each other in the triangle. They're on top of one another, so we must divide that out. So 200 divided by 0.62 is about 322.5 meters per second. Okay? Questions on number 3? All right. Let's look at number 4, and then I'm going to have you guys try number 5 on your own. Number 4, skier leaves the horizontal end of a ramp with a velocity of 25 meters per second. So remember, guys, everything we're doing here is horizontal projectiles, which means there's no angle to it. It's simply coming off a level plane. So it's traveling horizontally at 25 meters per second. Since this is the horizontal box and that is the speed, I'm going to put 25 there. And lands 70 meters from the base of the ramp. So if this is the base of the ramp, it lands 70 meters this way. So here's the ramp. Well, that kind of looks like an angle. Here's the ramp. The skier goes off and lands 70 meters. So that's a horizontal distance. So I'm going to put that there. I want to know how high is the end of the ramp from the ground. This one's a little bit different because now instead of starting on the vertical box, we're working with the horizontal component box first. Not a big deal. Still, we're solving for time. So speed, distance, and time. We have a distance of 70. We have a speed of 25. What's the time? Comes out to be 2.8. All right, so 70 divided by 25 is 2.8. What do we do with this time now? Yep, transplant it down to there, which is 2.8. Now we're going to solve for distance. We're trying to solve for vertical distance. Here comes everyone's favorite physics formula. We don't know d. We know gravity is 10. And we know that time is 2.8 squared. So this is easier. We don't have to do any square roots. We're simply going to do now 5 times 2.8 squared. We must square the 2.8 and then times that by 5, and it comes out to be, that is a large high ramp that someone will get killed if they actually jump off of it. 39.2 meters. questions with 1, 2, 3, or 4? All right, so what I want you guys to do is I want you to try number 5. The thing about number 5, guys, is this is taking place on the moon, not on Earth, so that's going to affect what G is. So it's telling us that acceleration due to gravity is 1/6 of that on Earth, so you can then figure out what G is on the moon. So I'm going to sign off here, and then I will give you guys a few minutes, and then I will come back to this, and we'll go over it.